to something linking then very closely the hypothesis testing to the confidence interval that we saw last time. And you will have seen that basically the building block seems to be the same. The mean, the standard deviation, the n, and the t distribution with n minus 1 degrees of freedom, right? These were the same building blocks that we used for the confidence interval, and it's very closely related, and here it comes. There would be a slightly different way to finish off or to make the conclusions on the hypothesis test. And that would be, here it comes. Let me show it here. That would be if I do it for the 5% level, I could find the t distribution even before I do my experiment, right? I could already now, because I know the t distribution, I could go and check what are these critical limits? When do I see something in the t that would make me reject something? And when do I see something that would just make me accept the null, right? This distinction between what is likely and unlikely, we can actually find that critical level up front before looking at the data by finding the proper quantiles. In this case, the 97.5, we've seen those before, and the 2.5% of the t. And then I jump back to this slide, because all this blah, 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 blah percentage, let's just read it. The 95% critical values would be the 2.5 and the 97.5 quantiles, called like that. These are, in a way, we call them the critical values for this t-test. And then we could finalize the hypothesis test that I just showed you without computing a p-value, but just making a yes-no decision, if that's what we would like to know. Should we accept or should we reject? Well, I just have to check whether my observed t-statistic, that was the one that was 4.67 in my example, is that within or without, right? Is it in the acceptance area or is it in the rejection area, right? And doing that, I can either reject or accept. That would be the critical value approach for doing the hypothesis test, you could say. So actually coming to a conclusion, yes, no, without actually quantifying it in a p-value. In a way, we can do it on the probability scale or we can do it on the quantile scale. It's one-to-one, whether we do it one place or the other. Yeah, this is the same plot. We accept when we are not too far away, and we reject when we are far away. I think it's pretty obvious. But then we have almost set and proved. I even bring a slide more where I make it more explicit. Now it should hopefully soon be clear, or at least if you go home and study it for a few minutes, that what I showed you last time was this as a confidence interval, 95% confidence interval, if I use it the most commonly done way, exactly includes those values that are accepted by the hypothesis test, right? The confidence interval are the acceptable values. Those outside the confidence interval are the rejectable values. So actually, by the confidence interval, so nice and intelligent tool, by the confidence interval, looking at that, I have tested all possible hypotheses like that. The proof is here. Yeah, that's what I just said. It is just so obvious, so I couldn't help bringing a slide, that if I'm inside the confidence interval with some potential value for the mean, then it's just very easy to see by two steps that it corresponds, of course, to the t-ops being within the acceptance area. In a way, it's just there are only those building blocks here, so it can be in no other way, in a way, right? So, This gives me, that was what I was sort of promising you last time. If you felt it hard to think about the confidence interval in this large sample meta frequentist way, which would be the right way last time to think about the confidence interval, here is a much nicer way to think of the same thing, which is not in contradiction in any way. It's just a different way to think about it. The confidence interval, and I said it, but I like to say it again, are those believable values for the mean, right? Those that are not included in the confidence interval, we don't believe. We would reject those by the hypothesis test. The acceptable ones, the rejectable ones. This is nice. This is good stuff for your future life and understanding of what's going on around you. Right? This was